Dear students, today we are going to study crystal field theory for octahedral complexes. So first of all, we should know about the position of d orbitals and how they split. So this is the crystal field theory. In short, it is called CFT. We know that there are 5 d orbitals in a complex. So the first one is dxy, dyz, dzx or xz, d x square minus y square, and the last d z square. So all these 5 orbitals, they arrange themselves in a definite manner. This is the square planar structure. X is the central metal, and these are the axes. Let it be y, this one will be x, and this one is z. So ligands arrange themselves in all these orbitals L stand for ligands. So this is the arrangement. Now in these axes the orbitals are arranged in this way. This is the x axis, y axis, and this is the z axis. At center, this is the x, which is a central metal atom, and an orbital lies on the z axis like this. It is called d z square. Another one, if orbitals lies on the x and y axis, like this, so they are called d x square minus y square. Here we have to note that these orbitals are on the axis, that is the z, this orbital lies on the z axis, so dz square, and these orbitals are lies on the x and y axis, so therefore it is called as dz square x square y square. And if orbitals are present between the axes, z, y, x, this is the first orbital, and another one, they are lies between x and y axis. So this is called dxy. Y x z, and they are the bipyramidal structures formed by 5 d orbitals. One orbital presents y and z axis. So this is called d y z, and the fifth one y axis, x axis, and this is the z axis. And orbital lies like this. This is the xz, this is the z, and this is the x axis. So this is called dxz. So they are the 5 orbitals and their positions. We have to note it down again that z square x square minus y square lies on the axis, while dxy, dyz and dxz lies between the axes. So what will happen? First of all, the points for CFT. First point, the metal, ion and ligands acts as point charges and interaction between them is electrostatic. The second point, when a ligand approach central metal ion, the electrons of the central metal atom and of ligands repel each other. The ligands approaching along the axis experience greater repulsive force. and therefore d orbital splits into two groups called T2G and EG. This is called crystal field splitting. Third point, electrons occupy splitting d orbitals according to Hund's rule. That is, those orbital having least repulsion filled first. Orbitals experiencing least repulsion are first occupied. The fourth point is the stability of complex is determined by CFSE, crystal field splitting energy, crystal field splitting energy. This is also called crystal field stabilizing energy.